For this problem, we have to make reference to the group we introduced in problem 11.3. And as a reminder, I've written here what this problem was. Remember, that was the set of all ordered pairs of real numbers in which a is not 0, right? And the operation that we introduced on this was defined by this weird operation here. And we proved that this is a non-abelian group. If you remember, we proved that if you have AB here, and an element of this set, then the inverse is equal to 1 over A and negative B over A, right? That's the inverse of this, which makes sense because remember A is not 0, right? And also the neutral element is 1, 0, okay? If you multiply this, so this number AB by this one, you will see, well, the operation is you multiply this by that, and then that is 1. And the second operation is you multiply is A by D, so this one by this one, which is negative B, and you add this one, which is B, therefore is 0. So you have the neutral. Okay, so these are the inverse and the neutral in this group here. Okay, but what we have to do now is to figure out, given these three subsets of G, which ones are subgroups of G, right? And for that, we're going to use the characterization of subgroups, which is the following. H is a subgroup of G. Well, let me use the notation for subgroups. So H with the product is a subgroup of G with this product if and only if x times y negative 1 belongs to H, right? For all x and y belonging to H, right? And by H here, I mean any subgroup. I'm not just referring to this one. I'm trying. You have to substitute this H by any one of these subset and see if this holds or not. All right, so let's begin with the first. Okay, these are just the elements of this set in which the second component is 0, right? Okay, let's take 1, right? That would be our x here, and another one, which is our y, and is a2, 0. And let's multiply 1 by the inverse of the other. So the inverse, well, this is x, so a1 times a0 times. And now we have to write the inverse of this. The inverse of this is 1 over a2, and here you have 0. So, right, this is the product of x times y minus 1, which of course is this by this is a1 over a2, okay? And the second component is this by this plus this, which is 0. And as you can see, this is also an element of H. So it satisfies this property, so this is a subgroup. H is a subgroup. Okay, what about B? Well, in B, we have elements of this form, so we do the same story. We take one element, this is going to be x, and we take a second element, 1b2, which is going to be y, right? And now we multiply the first by the inverse of the second. The inverse of 1 is, of course, 1, right? 1 over 1 is 1. And here we have negative b2, right? So we have to multiply these two numbers. This is the inverse of this, right? So if we multiply these two elements, what we have is this by this is just 1, right? And this by this plus this is b1 minus b2. And that, of course, belongs to t because it's of the form, this is t, because it's of the form 1 and a real number, just like you have here, okay? So T is also a subgroup, right? What about W? Well, for W, in W what you have is all the elements in which the two components are equal. All right, so let's take one element AA and try to calculate what the inverse is. Well, A is of course different from 0. That goes without saying. And then the inverse will be 1 over A, and the second component will be negative A divided by A, so negative 1, right? But this does not belong to W unless A is equal to 1. So only for one case, this belongs, well, sorry, when A is equal to negative 1. So only for one choice of A, this belongs to W. So in general, for any arbitrary A, this is not in W. Therefore, this element does not have the inverse in W, and therefore W is not a group. It's not a subgroup. Right? Does not have the structure of a group.